Hi everybody, hi, good morning guys. Welcome to Momentum with Vedantu. Welcome again to today's lecture. I'm so happy you guys are here. I'm so happy. Let me open this window. I'm so happy you guys are here. And today we are going to start with calorimetry. Now, guys, when I actually planned this session, when I was making the plan of this session, I wanted to finish this in one lecture. But going through it, I have realized that one session is it's not enough. It's not enough. Okay, so probably I will try to finish it today, but probably we will. mm, Finish this tomorrow. Okay, guys. Probably I'll try my level best to finish this today, but if not, then tomorrow, definitely. Okay, and what are we going to study today, guys? What are we going to study today? We are going to study calorimetry. Okay, we will try to finish this topic today, but probably will take one more class. Okay, hi everybody. Hi Hiralal Singh, Harneet Kaur. Welcome here. Hi Altaf Jam. Hi. Very good. Hi Sarthak. Hi JEE Study is also here. Hi, how are you? I think my chat is not refreshing. Okay, let us see now it refreshes. Yeah. Hi Balaji. Hi Pratik. Hi everybody. Zara. So many of you are here. Superb, guys. Superb. Now, before we move on, guys, first thing I want to tell you is you have to join our Telegram group if you want the lecture notes. Okay, if you want the lecture notes, whatever I'm teaching, whatever I'm writing, all that will be shared on this Telegram group. So you have to join it. Okay, I haven't shared yesterday's lecture yet. I will share that and today's lecture on the Telegram group. Okay, yes. Kartikeya Sharma is asking that he did not get the lecture of lecture notes yesterday. Yeah, we haven't shared. We will share by today. We will share. Also, regarding the Hall of Fame question, I will declare the winner in the next class. Okay, the Hall of Fame question, the homework question that I asked you, the person who gave me the correct answer, I will declare his name in the next class. Okay, today we are a little bit short on time, and I just forgot to do it. Okay. All right. No, I will. Priya Kartikeyan. I will share the lectures. Do not worry. Pankaj Kumar. I'm very good. How are you? Hi, everybody. So let's start. Let's start today's class. Okay, let's start today's class. Today we are going to start with calorimetry. Okay, before we start with calorimetry, I want to ask a question based on Radhika Gupta is asking to share the lecture notes in description box. Radhika Gupta, we are going to share it on the Telegram group. There is a reason why we are not sharing in the description. I don't understand, but it's very technical. Okay, so we'll share it in the Telegram group today for the both lectures. For the first and the second lecture, I will. Okay, I will. First lecture hasn't been shared today. We'll share it today. Okay. All right, guys. So first of all, let's talk about this warm-up question. Which of the following statement doesn't make sense? Which of the following statement doesn't make sense? The internal energy stored in this body is 20 joules, or the heat stored in this body is 20 joules. Okay, one of these two statements doesn't make sense. The other one makes sense. Tell me which one. Tell me which one. Kartikeya Sharma is asking for explanation of the homework. No, entertainment 2015 is asking for that. I will do that entertainment 2015. Tell me which one doesn't make sense. Tell me which one doesn't make sense. Correct. Option B doesn't make sense. Guys, you have to remember, whenever we talk about energy stored, we are always referring to internal energy. Okay, this is a nomenclature thing. Everybody has decided to call it internal energy. Okay, and whenever we talk about energy in flow, we are always talking about what, guys? We are always talking about this what heat. Okay, heat is always energy in flow. Okay, what do I mean by that? That if energy is taken out, okay, or given into the body, given to the body. Okay, whenever we use terms like this, we are talking about heat. Okay, heat is always energy in flow. It's either taken out or given in. Whatever is stored is called internal energy. Whatever is stored is called internal energy. Neat Avenger, I'm good, I'm good. Hi Altaf Jam, hi Harneet Kaur. Okay, so let's talk about internal energy. Okay, ये पता नहीं कहाँ से आ गया, इसको हटा देते हैं. Let's talk about internal energy. Okay, what exactly is internal energy? So guys, I have three different states of matter. I have three different states of matter. I have either solids, okay, or liquids or gases, okay, or gases. Okay, so what happens is, like, at room temperature, if we talk about at room temperature, what is happening is that the molecules of a solid are constantly vibrating in all directions. Okay, the molecules of this solid are constantly vibrating in all directions. So the energy stored due to this vibration, the energy stored due to vibration is called the internal energy. The energy stored due to vibration of molecules, is called the internal energy. Okay, there are two types of energy, by the way. The energy due to kinetic energy of vibration, and there is also potential energy. All the solid molecules are holding each other very, very tight. Okay, because they are holding each other very, very tight, there is also potential energy associated here. Okay, so the total of that potential and that kinetic energy is called, total of that potential energy plus kinetic energy is called internal energy. That is called the internal energy. The total of energy stored by the vibration of molecules and the potential energy because of forces of attraction is called internal energy. Okay, hi Kriti Rastogi, you want me to be a little slow? Okay, I will solve it a little, I will go a little slow. Okay, now, similarly, if you look at molecules of liquid, the molecules of liquid do not vibrate in general. What happens there is they are constantly moving about and colliding and changing their paths. Okay, they're constantly moving about, then undergoing collision and then changing their path. So here also molecules have some energy stored in that. Okay, and here this internal energy, internal energy is due to what? Is due to the kinetic energy, okay, plus the potential energy. The kinetic energy, because why? Because of which they are moving around, and potential energy due to attraction between the molecules. You have to remember, guys, that here also in liquid also there is a lot of potential energy due to attraction between the molecules. Okay, why do I know that there is attraction between the molecules? Because if there wasn't any attraction, the molecules will just go far away from each other, and instead of liquid we will have a gas on our hand. Okay, so by definition, if it is liquid, that means that molecules have attractive forces between them. Okay, similarly in case of gases, once again the molecules are constantly going around colliding with each other and so on. Okay, so here also there is due to internal energy due to kinetic energy of molecules. Okay, but in case of gases, what happens is that the potential energy is negligible. Okay, in case of gases, the potential energy is negligible because the attractive forces between the gas molecules is almost non-existent. Okay, so we just ignore its potential energy. We just write it as kinetic energy. And by the way, if there is no potential energy, we call such a gas as an ideal gas, which we will study later in KTG. Okay, so internal energy is what, guys? Internal energy is energy associated, okay, with molecules of a body, okay. And you have to remember one more thing here, guys. You have to remember one more thing here, that higher temperature means what? Higher temperature of a body means what? Higher temperature means, okay, that each molecule, average energy of each molecule is high. Average energy of each molecule is high. is high. Okay, I hope my handwritings are good. I hope my handwriting is good. Average energy of each molecule is high. You know what? Let me just write again in a better handwriting. Molecule is high. Okay, H नहीं होता मेरे से H. Okay, I hope everybody understood. Jai Shri Krishna, Altaf Jam. Okay, hi everybody, hi. Okay, so I hope everybody understood. Avikarya, yes, potential energy is not there in gases. Okay, yes, Neet Avenger, I love my class too. I really love my class. Okay, thank you so much for you also to love my class. Okay, so let's talk about next thing. Okay, काफी आगे चला गया मैं गलती से काफी आगे चला गया. Let's talk about the next thing. Okay, and what is that? Mechanical equivalent of heat. Okay, mechanical equivalent of heat. What exactly, guys, is mechanical equivalent of heat? Okay, so this is a term which was defined long ago, before we realized that heat and work are basically just two different forms of energy. Okay, so what we have here is, let's say I have two different containers containing equal amounts of the same liquid, now in one container I am doing some work, by rotating the fans and everything and trying to raise the temperature of the liquid. Okay, by the way, this work done is measured in joules. The work done is measured in joules. Okay, and in the second container, what I'm doing is I'm giving this container heat to raise the temperature of the body. Okay, here this heat is measured in calories. Okay, so what exactly is mechanical equivalent of heat? What we say is that if temperature difference, if a change in temperature is same for both cases, okay, then what I can say is that the work done here is going to be directly proportional to the amount of heat given. Okay, like the more amount of heat you give, the more work you will also have to do for the temperature change to be the same. Okay, and if I want to remove the proportionality, what will I add? I will add a constant here called J. Okay, guys, now you have to remember here the work done here is measured in joules and the heat is measured in calories. Okay, so actually when I tried to measure the value of this J, it came out as delta W by delta Q. And what I realized is that in order to have same amount of temperature change, each calorie is equivalent to 4.2 joules of work. Each calorie is equivalent to 4.2 joules of work. Okay, guys, so what I can say is that the value of this J, the mechanical equivalent of heat, is nothing but 4.2 joules per calorie. Now, guys, this term was invented before we knew that calorie is just another unit of energy, just like joules. Okay, so at that point of time we didn't know this. Now if I had to measure this heat also in calories, if I had to measure heat also in joules, then iska value सीधा 1 के बराबर हो जाता. Okay, but in general you have to remember, when heat is measured in calories and work is measured in joule, then the mechanical equivalent of heat is 4.2 joules per calories. Guys, थोड़ा सा भी कचरा हो रहा है इसमें because the space is low this time. Okay, but I hope everybody understood so far. ठीक है, I really hope everybody understood. All right, guys. All right. Yes. Okay, I hope everybody understood. Okay. All right. Shravani Reddy is asking me to repeat internal energy in liquid. Shravani, it wasn't very important. Please go back and watch the video. You will understand. Okay. All right. Next is specific heat capacity. Guys, everybody should know the definition of a specific heat capacity. Okay, if you don't know the definition of specific heat capacity, then let me tell you. Okay, because I think there are very few ICSE people there. If you're an ICSE student, you would already know what this means. But if you are not an ICSE student, then you wouldn't know what I mean here. Okay, so what exactly do I mean here? So See, very simple. Okay, very simple. Understand this. Let's say I have a body. Okay, let's say I have a body, and this body is at an initial temperature. This body is at an initial temperature of Ti. Ti stands for the initial temperature. Okay, yeah. So many, not many of you are of ICC. Okay, anyways, thank you, Royal. Okay, next, what happens is I want to increase the temperature of this body. I want to increase the temperature of this body from some Ti to Tf. I want to increase the temperature of this body from some Ti to Tf. Okay, so here if I ask you what is the change in temperature, here if I ask you what is the change in temperature, so guys, you have to remember the change in temperature always written as delta T, and is going to be nothing but always final minus initial. Guys, you have to remember this here, next year, every time. Always remember, change is final minus initial. Change is final minus initial. Okay, so the change in temperature will be written as the final temperature minus the initial temperature. Okay, now what will I need to do to change its temperature? What will I need to do to increase its temperature? I will need to give it some heat. I will need to give it some heat. Okay, now you have to understand that the amount of heat that I will need to give this body will be directly proportional to the delta T. Okay, what this essentially means is that if you want to increase the temperature more, you will have to give in more heat. Okay, if you want to increase more temperature, give in more heat. If you want to increase less temperature, give in less heat. Okay, the more the heat given is, the more the temperature change will be. I hope everybody understood. I really hope everybody understood. Okay, all right. Next is if I take the mass of this body as m, then I also can say that the delta Q, the amount of heat given, should be proportional to m. What I mean here is that the more the mass of the body is, the bigger the body is, the more heat I will need to give it to heat it up. Okay, to heat up the body, if the mass is bigger, I will have to give in more heat. So that's why delta Q is also proportional to also proportional to m. If I combine the two, what I get is delta Q is proportional to m delta T. Now, if I want to remove the proportionality, guys, what do I add? If I want to remove the proportionality, what do I add? Tell me in the chat. Tell me in the chat. What do I add? Yes, correct. If I want to remove the proportionality, I have to add a constant. Okay, this constant here is called C. This constant here is called C, and C is called specific heat capacity. C here is called specific heat capacity. Okay, correct. Okay, and this constant has a special name. It's called specific heat capacity. I hope everybody understood, right? I hope everybody understood. I really hope everybody understood. All right, guys, let me add a new slide here. I will need a new slide. Okay, let me change the layout of this slide as well. Let's make it blank. Wow. Okay, so in this case, I have the formula delta Q is equal to mc delta T. Okay, delta Q is equal to mc delta T. Now, if I rearrange, I can write the C is equal to delta Q upon m delta T. C is equal to delta Q upon m delta T. Okay, now very big question, guys. Very big question. Okay, what is my JEE rank? 692 Hamshad Dwaj. Okay, so very important question here, guys. Very important question. If if I double if I double the value of m, you know what, I'll just ask you this. If I double the value of m, what will happen to the value of C? If I double the value of m, what will happen to the value of C? Tell me on the chat. What will happen to the value of C if I double the value of m? Everybody, what will happen to the value of C? Sujit is saying it will become half, Mathislav is saying it will become half, and Tanish is also saying it will become half. Guys, all of you are wrong. Okay, and this is where you have to pay very close attention. Okay, if m is double to 2m, then delta Q will automatically double to delta Q. Okay, what happens is C remains the same. You have to remember this, guys. C is the constant of proportionality. Here, this C is a constant. This C is a constant. Okay, it will not change. It will not change. It will remain the same. Exactly, smart book is correct. Okay, so if M is doubled, delta Q will get doubled, but C will remain the same. That is what you have to understand. Okay, that is what you have to understand. C is the constant of proportionality. We call it constant because its value does not change. Its value does not change. I hope everybody understood. I really hope everybody understood. Okay, now next slide, guys. Once again, I have delta Q. Once again, I have delta Q is equal to MC delta T. Okay, which gives me C will be equal to delta Q upon M delta T. If I ask you, what is the SI unit of C? What is the SI unit of C? Can you guys tell me what is the SI unit of C? Yes, 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 yes. What is the SI unit of C? What is the SI unit of C? That will be equal to SI unit of delta Q, which is joule per kg per Kelvin. Okay, it will be equal to joule per kg per Kelvin. I hope everybody understood. I hope everybody understood. Okay, and what will be the CGS unit of C? What will be the CGS unit of C? Then you have to remember, guys, in CGS the unit of heat is calories. Okay, so it will be calorie per gram per degree Celsius. It will be calorie per gram per degree Celsius. I hope everybody understood. I hope everybody understood. Okay, really hope everybody understood. Alright, are you guys noting this down? You don't need to note this down, guys. You just need to pay attention. Okay, you just need you just need to pay attention. Okay, and you will get the notes on the Telegram group. You will get the notes. Do not worry. So one question, guys. I have specific heat capacity of a body given in calories per gram per degree Celsius. You have to tell me its value in joule per kg per Kelvin. Do you guys know how to convert it into joule per kg per Kelvin? You have to convert it into joule per kg per Kelvin. Everybody, tell me the correct answer in the chat. Okay, I'll give you 1 minute, guys, to solve. Medha Amshikar is asking, sir, C is also written as S. Yes, Medha, in some books, C is also written as S. C is also written as S. Okay. So in my classes, I will use the term C to mean specific heat capacity. In some books, okay, it's written as S. All right. Yeah. Rehan, share the notes. Start sharing the notes from today. Okay. All right. Tell me, guys. Tell me, fadafat say what will be the value? What will be the value? Everybody. How will I calculate? So I know, guys. I think everybody should know that how much 1 calorie is. Everybody knows how much 1 calorie is. 1 calorie is 4.2 joules. Okay, and I hope everybody knows that 1 kg is basically how much? It's basically 10 power 3 grams. 1 kg is basically 10 power 3 grams. I hope everybody knew this. Okay, so based on that, I can also write 1 gram is equal to 10 power minus 3 kgs. 1 gram is equal to 10 power minus 3 kgs. Okay, and finally, guys, tell me, 1 degree Celsius, if I had to convert it into Kelvin, how many Kelvin it will be? If I had to convert 1 degree Celsius into Kelvin, how many Kelvin will it be? In the chat, everybody. See, we have discussed this yesterday. Okay. Will it be bought? I will give you two options. Okay, I'll give you two options. Option number one, you know what? I'll give you three options. Option number one is 273. Option number two is 274. Kelvin. And option number 3 is 1 Kelvin. Tell me, 1 Kelvin, 1 degree Celsius will be equivalent to what? 1 degree Celsius will be equivalent to what? 273, 274 or 1? 273, 274 or 1? Everybody has to tell me. Everybody has to tell me. Okay. See, you guys, if you have attended my class yesterday, you would know that the correct answer, then you would have to know, the layout, you don't understand when I change the layout. What? Yeah, PowerPoint. What? Yeah. Okay. So if you have attended my class yesterday, guys, you would know that this is wrong and this is also wrong. The correct answer is 1 Kelvin. Okay. The correct answer is 1 Kelvin, guys. You have to understand why I am saying that. You have to understand why I am saying that. Okay. So you for that look at the formula for this. Okay. So formula for C is what? Delta Q divided by M delta T. Here delta T represents what, guys? Here delta T represents what? Change in temperature. Delta T represents what, guys? Change in temperature. Okay, everybody remember, delta T represents change in temperature. Okay, so if I'm talking about change in temperature, let's say I talk about change in temperature of 1 Kelvin. Let's say for a body, initial temperature was 10 degrees Celsius and the final temperature was 11 degrees Celsius. So what will be the change in temperature of this body? It will be 1 degree Celsius. But if I ask you how much is the change in temperature in Kelvin, oh my god, tell me, what is the change in temperature? What is the change in temperature in Kelvin? It is also 1 Kelvin. Okay, the change in temperature is same. The change in temperature is same on both scales. Okay, the change in temperature is same on both scales. Delta T here represents not temperature but change in temperature, guys. That's why I'm asking you to pay very close attention. Okay, we are going to focus a lot on basics because I know where people make mistakes. Okay, so coming back to this, 1 degree Celsius corresponds to 1 Kelvin. Everybody should know that 1 degree Celsius corresponds to 1 Kelvin. Okay, so substituting this here, I get C is equal to 0.6 into 4.2 joules divided by 10 power minus 3 kg into 1 Kelvin. Okay, you have to remember 1 calorie I have substituted 4.2 joules here, and you know what, I will write again on a new page so that nobody gets confused. Okay, यार ये layout हमेशा ये ऐसा ही क्यों आता है? Okay, so I will write again here. I can write C is equal to 0.6 calorie per gram degree Celsius. That can be written as 0.6 into 4.2 joules, because 1 calorie is 4.2 joules, into 10 power minus 3 kgs. Okay, because 1 gram is 10 power minus 3 kgs, and into 1 Kelvin, because 1 degree Celsius, guys, corresponds to just 1 Kelvin. Okay, this I don't know how much will this be. Oh my god, 4 6 are 24, 2 6 are 12, 2.52. Yes, 2.52 into 10 power 3 joule per kg per Kelvin. Okay, I hope everybody understood. I really hope everybody understood. Okay, 1 degree Celsius is same as 1 Kelvin if you're talking about change in temperature, guys. If you're talking about change in temperature, I hope everybody understood. Okay, one question for you guys. Very simple question for you guys. Very simple for you guys. Simple questions for you guys. Find the amount of heat required to increase the temperature of 40 gram of water from 20 degrees Celsius to 65 degrees Celsius. I want the answers in calories. Okay, now guys, before you solve this question, you have to remember some data. Okay, remember some data. Okay, the first important piece of data that you always have to remember is the specific heat capacity of water. Okay, everybody should know the specific heat capacity of water. How much is that? Everybody should know this. Tell me the answer in the chat. Exactly, it is equal to 1 calorie per gram per degree Celsius. Okay, if you try to convert this into SI units, this will become 4200 joule per kg per Kelvin. Okay, if you convert it into SI unit, this is the first piece of important data that everybody should know. Okay, the second and third which you should know, I will come back to it when we get to that. Okay, when we study latent heat of fusion, we'll talk about this. Exactly, Poshina, Hiralal Singh, Balaji 11, everybody is correct. Everybody is correct. Yeah, Sarthak is saying, sir, it should be 4186. Sarthak, yes, exactly, it should be 4186, but we always approximate it to 4200. Okay. All right. Thank you, Hamzat Vash. Thank you. So, how much will this be, guys? How much will this be? Find the amount of heat required to increase the temperature of water from 40 gram of water from 20 to 65 degrees Celsius. Okay. All right, guys. All right. So, how will I do this? How will I do this? It's very simple, guys. I will add a new slide here. Okay, new slide, and you better be no. You will never be a blank slide. Okay, you will never be. कोई मेरी सुनता ही नहीं है यहाँ पे. Okay, so you just have to use the same formula. See, first of all, Anna, I would love it if you write it in the equation form. Okay, so you have what? You have 40 grams of water. You have 40 grams of water at 20 degrees Celsius, and you want to convert it to 40 grams of water. You want to convert it to 40 grams of water at 65 degrees Celsius. Okay, and for this you have to calculate the heat given to the water. For this you have to calculate the heat given to the water. So you can just write delta Q is equal to MC delta T. Remember, here delta T is change in the temperature, that is always final minus initial. Okay, change in temperature is always final minus initial, which in this case will be 65 minus 20, that is nothing but 45. Okay, substitute everything here. You will get delta Q is equal to 40, which is mass, into C, which is 1, into 45. Okay, now 45 into 2 is 90, 45 into 4 is 180, so this will be 1800 calories. This will be 1800 calories. I hope everybody understood. Okay, fine. I hope everybody understood. Okay. Hamshadwaj is asking, sir, why increase in temperature? Hamshadwaj, I don't understand your question. Why increase in temperature? Because here it's going from 20 to 65, so temperature is increasing. Temperature is increasing. I hope Hamshadwaj you understood. Okay, really hope Hamshadwaj understood. Okay, now here, guys, I need to talk to you about something important. Okay, I need to talk to you about something important, and that is called sign convention. Okay, sign convention. So guys, you need to remember that this is physics. This is not chemistry. Okay, this is physics. Okay, what do I mean by this? Let's say I have a body and I give it a heat of 20 calories. If I have a body and I give it a heat of 20 calories, I can write delta Q is equal to plus 20 calories. Okay, giving heat to a body means positive heat is given to the body. Okay, what do I mean by that? If I have another body and I'm taking out heat, if I'm taking out heat of, let's say, 15 calories, then in this case I will write delta Q for the body as negative 15 calories. Okay, things are a little bit different in chemistry. I won't go into what they are exactly because that is chemistry, not my domain. But in physics, if heat is going into the body, we consider it as positive. If heat is going out of the body, you call it negative. All right. Okay. This is the body which we are talking about. If heat is going out, you write it as negative. If heat is going in, you write it as positive. Okay. So based on that, guys, you have to tell me the answer to the next question. Okay, the next question is this. I'll give you 1 minute to solve, everybody. I will give you 1 minute to solve. फटाफट से बताओ. Sadhvaj, the body which is shown in the diagram, if heat is going into the body, you call it positive. Okay. All right. Everybody, tell me the answer. Rishu Prasad, overall, the entire heat topic has approximately 15% of weightage, 15% of weightage in the book. Okay, so what will I do here, guys? How will I solve this? I will write See, water going from 40 degree to 25 degree Celsius. First of all, I will write the change in temperature, which is final minus initial. What will be the change in temperature here? That will be 25 minus 40, which is negative 50. So delta Q is given as what? Delta Q is given as MC delta T, which in this case will be equal to 10 into 1 into minus 15, which gives me delta Q is equal to negative 150 calories. Now, what does this negative sign mean? What does this negative sign mean? The negative sign means heat is taken out of water. Heat is taken out of water. Okay, or water is cooling down here. And this is very obvious. If you see the temperature of the water is going from 40 to 25, that just means that the temperature of the ये नहीं जाएगा. Okay, that just means what? That just means what? That the temperature of the water is decreasing. I hope everybody understood. I hope everybody understood. Okay, negative means heat is taken out. Okay, I hope. Yeah, everybody understood. Everybody understood. Okay, so now based on this, before going to this, let's do one more question, guys. Let's do one more question. And this is a little bit of a weird question, but everybody should know how to solve this. Okay, ये जा ही नहीं रहा है यहाँ से. Why are you doing this? Go away. Go away. It won't go. It won't go. I don't know why there is this here. Okay, let me try to maximize the screen and then minimize the screen. Nope, it's still not going away. It will not go away, guys. Anyways, chalo, solve this question. Okay, I know there is a line in between which is disturbing you, but solve this question still. Rishu Prasad is asking, sir, which book should be referred for physics for NEET? You can refer to for NEET, guys. I don't know why, but I love one set of books which I love, which I've fallen in love these days, and that is the NCERT books. If you're a NEET student, you should definitely read NCERT. Okay, once you're done with that, you can go to any reference books you want. You can read DC Pandya or anything else. Okay, HCV or anything else. But first you should finish. Cengage is also very good, yes. But first you should finish NCERT. Alright guys, anybody give me the answer for this. Alright, anybody give me the answer, guys. Give me the answer. I have a hammer which has a speed of 50 meters per second hitting an iron nail of mass of 200 grams. If the half of the kinetic energy is converted into heat, find the rise in temperature of the nail. Okay, so no Sarthak, I am teaching according to JEE. Okay, so I will start with NCERT and go about. Don't worry, Sarthak, I will teach about till JEE. Do not even worry. Okay, so let's talk about this question. I have a hammer of mass 1 kg, speed of 50 meters per second. It's an iron nail of this. So first of all, I need to calculate how much kinetic energy of this nail is. You guys know what is the formula for kinetic energy? Yes, correct. The formula for kinetic energy is half mv square. Guys, how much will that be equal to? How much will that be equal to? Half into 1 into 50 square. That will be equal to 2500 divided by 2, 1250 calories. So 1250 joules. Okay. Alright, so if I ask you therefore how much heat will be given to the iron nail, the heat will be given to the iron nail will be half of the kinetic energy. That will be 1250 divided by 2. That will be, I think, 625 joules. Okay, I hope everybody understood. But remember here, guys, the heat given to me here, the heat that we have calculated here is in joules. Okay, is in joules, and the specific heat given to us here is in calories. So what do we do here? What we'll do is very simple. We will convert the heat into calories. Okay, so I have what? Oh my God, go away. You can't go away. Chal. Why is this still here? I don't want you here, man. Just go. Okay, what I can say is that the heat is 625 joules. Okay, that will be nothing but 625 into 1 divided by 4.2 calories. 1 divided by 4.2 calories. This is how you convert calories to joules. Okay, so that is 625 divided by 4.2 calories. Now you can just write, guys, now you can just write delta Q is equal to MC delta T. In this case delta Q is 625 divided by 4.2, that is equal to M, which is given as 200 grams, into C, which is given as very bad value, 0.105 calories per grams per something something, into delta T. Okay, which gives you finally okay, blank, which gives you finally, what does it give you? It gives you delta T is equal to 625 divided by 4.2, okay, into 200 into 0.105. Guys, my maths is weak, so let's just use calculator. It will be equal to 625 divided by 4.2 divided by 200 divided by 0.105. That will be approximately equal to 7.08 degrees. That will be equal to 7.08 degrees Celsius. I hope everybody understood. Okay, we are supposed to calculate delta T. I hope everybody understood. Okay. Alright, do I have a white colored brush here? I don't think I have a white colored brush here. Why is this not going? ये जीवन ही खराब है. जीवन इतना खराब है, guys. जीवन इतना खराब है. What to do here? Okay, what to do here? I don't know what to do. ठीक है? Alright, चलो. नहीं यार, ये नहीं काम बनेगा. ये इससे काम नहीं बनेगा. You know what? I'm going to close this and open this up again. Okay, I'm going to close this and open this up again. Let's hope that works. Okay. What happens when I close this? When I close this. Okay, before class. Oh, nothing is there. Oh. Let me try to open this up once again, guys. Let's go here. Of the T's. PowerPoint. Okay. Yeah, it's here. I'm so sorry, guys, for whatever it was. It should be gone by now. If it's not, yeah, gaya. Okay. Class 12th class is at 4 p.m. guys. Class 12th class is at 4 p.m. You can come back. Okay. Am I lagging? Yes, I am lagging. No, I'm not lagging. Okay, chalo, I'm not lagging. Okay, alright guys, so now you have to understand that we have two different types of specific heat capacity. Okay, the first specific heat capacity was here. Okay, this is called gram specific heat capacity, and it's written as small c. Okay, it's written as small c. We have one more different type of specific heat capacity, guys, which is called molar specific heat capacity. This is called molar specific heat capacity, and we are going to denote it with capital C. Yes, Rishu Prasad, this is JEE and NEET level. Okay, this is JEE and NEET level. So what exactly is molar heat specific heat capacity, guys? Once again, it's the same thing. Let's say I have a body and I want to change its temperature from Ti to Tf, some initial temperature to some final temperature. Then the change in temperature will be final minus initial, which is Ti minus Tf. Okay, and in that case I will have to give heat to this body. And the amount of heat that I have to give to this body is directly proportional to the change in temperature. The more the temperature of the body is, the more the heat I will have to give. Okay, now next thing you have to understand is that if I have the number of moles here as n, if I have the number of moles of this body here as n, okay, then the amount of heat that I have to give to this body is also proportional to n. The more the number of moles of this body is, the more heat I will need to give. So if I combine both these, I will get delta Q is proportional to N delta T. Okay, and if I remove the proportionality, what will I need to add? If I remove the proportionality, I will need to add a constant. Okay, and this constant will be equal to capital C. This constant will be equal to what? Capital C. Here C is called this capital C is called molar specific heat capacity. Molar specific heat capacity, that is capital C. Okay, that is capital C. Akshay Kaushik, no, this is the second class. The first class happened yesterday, but you can still watch it today if you want. Okay, I hope everybody understood here, guys. I hope everybody understood. Okay, and now if this is the molar specific heat capacity, I can write it as C is equal to delta Q upon N delta T. If I ask you what is the SI unit of a C, what will be the SI unit of capital C? That will be nothing but joule per mole per Kelvin. Okay, joule per mole per Kelvin. Okay, now in general, when we talk about molar specific heat capacity, that will be molar specific heat capacity, that will be for mostly we talk about molar specific heat capacity when we are talking about gas. Okay, for solids in general we take gram specific heat capacity. This is called molar specific heat capacity. Okay, now I hope everybody understood. Sarthak Aher is asking, sir, what is Boyle's law and what is Charles' law? Sarthak, come back here when I'm teaching KTG and you will be explained everything. Okay, come back here when I'm explaining KTG and you will understand that. I hope everybody understood, guys. I really hope everybody understood. Okay, so now relation between capital C and small c. Okay, relation between capital C and small c. You have to remember, guys, this capital C is what? Capital C is molar specific heat capacity and the small c is gram specific heat capacity. Okay, so what is the relation between this? What is the relation between the two? You have to understand that if I have any body or any material, they will have both the specific heat capacities defined for them. They will have the gram specific heat capacity defined for them, and they will also have molar specific heat capacity defined for them. Okay, I just want to know that for that body, what is the relation between the two? Okay, Altaf Jam is asking what is my birth date. Altaf, it comes on International Women's Day. Okay, so now in this case, let's say this body, this body has mass equals to m, and molar mass is equal to capital M. Okay, so if I'm going to give some heat to this body, what will happen is that the temperature of this body will increase. Change in temperature, let's say, is equal to delta T. So guys, what can I write? Guys, what can I write? I can write from the gram specific heat capacity equation, I can write, okay, from the gram specific heat capacity equation, I can write that delta Q is nothing but mc delta T. Delta Q is equal to nothing but mc delta T. This is small c, okay? This is small c. Also, I can write from the molar specific heat capacity equation, delta Q is equal to N capital C delta T. Delta Q I also can write as N into capital C into delta T. Okay, alright. I hope Legendary Gaming on Vedantu platform. Which batch do I teach? I teach the Sankalp and the Drishti batch. Okay, I teach the Sankalp and the Drishti batch. Okay, so in this case, guys, what can I say? I can just say, if you look at this, guys, I had two different equations. Delta Q is equal to mc delta T, and delta Q was also equal to n capital C delta T. If I equate the two, I just get mc delta T is equal to n c delta T. Okay, one is capital, one is small. Okay, I hope everybody understood. I hope everybody understood. All right. Okay, guys. Okay, do you guys understand? Hopefully. So now I can write, if you know that number of moles, okay, which is N, is nothing but mass divided by molar mass. Number of moles is nothing but mass divided by molar mass, which will be M divided by capital N. So substitute that here, guys. I get mc delta T is equal to M by capital M into capital C into delta T. something gets cancelled out here, some things will get cancelled out here, and I will get finally capital C is equal to molar mass into small c. Molar specific heat capacity, guys, is equal to molar mass into gram specific heat capacity. This is an important equation because we will keep coming back to this. There will be direct questions based on this, so please remember this. Okay, it's a very important equation. The molar specific heat capacity is equal to molar mass into gram specific heat capacity. I hope you guys understood. Okay, now let's talk about thermal capacity. Okay, guys, thermal capacity also has some other name. Can you tell me the alternate name for thermal capacity? What is thermal capacity also called? It is also called, exactly. It is also called heat capacity. Okay, heat capacity. Okay, thermal capacity is also called heat capacity, and heat capacity, by the way, we denote it with letter H. Okay, what exactly is this? What exactly is this? Here we can just say that heat capacity is nothing but mass into gram specific heat capacity. Mass into gram specific heat capacity. Here H is nothing but M into C. Okay, so if you remember, we have written delta Q is equal to M into C into delta T. We can just write it as delta Q is equal to H delta T. Now sometimes in the exam H will be given to you. Sometimes in the exam H will be given to you rather than the C and M. Okay, so you just have to use this equation. You just have to use this equation and everything will be okay. By the way, delta Q is equal to H into delta T, where H is the heat capacity. What will be the value? What will be the value of H? That will be delta Q by delta T. If I ask you what is the SI unit of H, what will be the SI unit of H? That will be equal to calojoule per Kelvin. Okay, and if I ask you the CGS unit of H will be equal to how much? That will be equal to calorie per degree Celsius. Okay, the unit of heat capacity is different from unit of specific heat capacity. I hope everybody understood. Okay, now based on this, guys, one question for you guys. Specific heat capacity for aluminium is this. Find the heat capacity of 24 grams of aluminium. Everybody tell me. Okay, ऑलराइट प्लीज प्लीज ओ माय गॉड, चैट में फाइट्स चल रही है यहाँ पे। ओहो, किसके बीच में फाइट चल रही है? ओहो, डोंट फाइट गाइस, वी आर ऑल हियर टू लर्न रे। व्हाट हियर, व्हाट टेल मी गाइस, व्हाट विल बी द स्पेसिफिक हीट कैपेसिटी? थैंक यू हीना, थैंक यू। टेल मी गाइस, टेल मी व्हाट विल बी द हीट कैपेसिटी? टेल मी। सुरेंद्र is correct, Priya is correct, Sarthak गलती कर दी, my friend गलती कर दी। Guys, you have to remember H is nothing but M into C, which in this case will be equal to 24 into 0.1, which is nothing but 2.4 calories per degree Celsius. How did I choose calories per degree Celsius? Because this is in calorie per gram per degree Celsius and this is in grams. Okay, so overall it will become calories per degree Celsius. Yes, exactly. Dr. Strange is correct, Tamanna is correct, Vedant Kulkarni, Amit Kumar, everybody is correct. Altaf Balaji, yes, everybody is correct. Very good, guys. Arshita is also correct. Okay, now let's talk about principle of calorimetry, guys. Let's talk about principle of calorimetry. Okay, what exactly is principle of calorimetry, guys? What exactly is principle of calorimetry? It's very simple. Okay, and that is this, that if I have two liquids, okay, let's say I have first container. In this I have liquid 1. Okay, it is at some temperature 20 degrees Celsius. Okay, and in the second container I have another liquid 2, and this is at, let's say, temperature of 70 degrees Celsius. So now if I mix the two liquids, what will I get? In that case I will get the mixture of the two liquids, 1 plus 2 here. Okay, and it will be at some intermediate temperature. Okay, it will be at some intermediate temperature of, let's say, T degrees Celsius. Okay, so in this case, guys, you have to understand that this T will be between 20 and 70. So one liquid here will get heated up, one liquid here will get heated up, and another liquid here will get cooled down. Can you tell me which liquid will get heated up? Yes, correct. Liquid 1 will get heated up, and which liquid will get cooled down? Liquid 2 will get cooled down. Okay, so what I mean from this is that if I write down the equation, okay, for both of them, if I write down the equation for both the liquids separately, then for liquid 1 it was initially at 20 degrees Celsius, and finally it went to T degrees Celsius. And for liquid 2 it was initially at 70 degrees Celsius, and finally it went to what? Finally it went to T degrees Celsius. Okay, now when I'm mixing the two, one of them cools down and one of them gets heated up. So out of these two values, out of this delta Q's, okay, one delta Q will be negative and one delta Q will be positive. Can you tell me which delta Q will be negative, delta Q1 or delta Q2? Yes, correct. Delta Q2 will be negative. Okay, very good, Tamanna, very good. Yes, this class is going to go until this class started at 12 o'clock, Tamanna, and will go until 1 o'clock. Okay, so here what I can say is that delta Q1 in this case will be positive and delta Q2 in this case will be negative. Okay, but what you have to understand here, guys, is this. Since I am just mixing these two liquids and not adding any more energy, okay, I'm just mixing them, I'm not adding any more energy. So what I can simply write is, because one of them is losing energy, one of them is gaining energy, there is no energy coming from outside, the sum of both these delta Q1 and delta Q2, the sum of both these delta Q's will be 0. Sum of both these delta Q will be 0. Why am I saying this? Because of, correct, this is because of conservation of energy. You have to remember that energy can neither be created nor be destroyed. Okay, it can only be exchanged between these two liquids. So if one of them is losing energy, other one is gaining energy, the total sum will be equal to 0. One of them is losing energy. You have to remember delta Q2 is negative. Because I'm taking heat out of 2. Okay, and delta Q1 is positive because I'm giving heat to 1. Okay, and the amount of heat that I've taken out will be same as the amount of heat given in. So sum will be equal to 0. The sum of both of them will be equal to 0. I hope everybody understood. I really hope everybody understood. Okay, yes, correct, Amay Karwarkar, correct, Supriya Gupta, both of you are correct. Dr. Strange, yes, this is exactly because of law of conservation of energy. Okay, guys, I hope everybody understands. The total heat will be 0. The total heat given to the system will be 0. So delta Q1 will be plus delta Q2 will be 0. Okay, everybody should remember this. Now, based on this, guys, I want you guys to do one last question for the day. I have 20 gram of liquid A, which has specific heat capacity C and temperature this, is mixed with 30 gram of liquid B at temperature this. Okay, you have to find the final mixture of the temperature. It's a very easy question, guys. Okay, it will take you around 1 or 2 minutes. Arshita, it's okay. Just watch this last question. Okay, at home. Tell me what will be the value, guys. What will be the value? Everybody tell me. Yes. What will it be? See, what you can say, guys, here is this, that I have liquid A which has mass 20 gram and initially at 25 degrees Celsius. When I mix it with B, let's say it goes to a certain temperature. T degrees Celsius. I have mixed it up with B, so its temperature will increase. Let's say it goes to T degrees Celsius. Let's say this heat is delta Q1. Okay, so what I can write is delta Q1 is nothing but MC delta T, which in this case will be equal to 20 into C into T minus 25. 20 into C into T minus 25. Guys, remember delta T is always equal to final minus initial. Delta T is always equal to final minus initial, which is equal to T minus 25. Okay, I hope everybody understood. I hope everybody understood. Now, similarly, if I had to talk about the second liquid, the B liquid, okay, it has a mass of 30 grams and it is at a temperature of 45 degrees Celsius. It goes to a temperature of T degrees Celsius because finally the temperature for both of them will be same. And let's say here the delta Q is 2. What will be delta Q2, guys? What will be delta Q2? That will once again be MC delta T, which in this case will be mass of this is 30. The specific heat capacity of B is 2C, and delta T in this case is final minus initial, which is T minus 45. Okay, now what I can just write, guys, what I can just write is what I can just say delta Q1 plus delta Q2 will be equal to 0. Okay, or 20 into C into T minus 25 plus 30 into C into T minus 45 is equal to 0. Okay, Altaf Jam, you have to remember. See, Altaf Jam is saying it will be 45 minus T. Altaf Jam is saying it will be 45 minus T. Altaf Jam, you have to remember the change in temperature will be what? Final minus initial. It will be final minus initial. That will be T minus 45. Okay, here this will be a negative value. I know that this will be a negative value, and that means this delta Q2 will also be a negative value. That doesn't matter to me. That doesn't matter to me. Okay, but overall delta Q2 will be negative. So I will add one positive quantity, one negative quantity. Their sum will be 0. Okay, which gives me, if you see, oh god, I forgot to write 2C. This will not be C, this will be 2C. Okay, if you see, some things get cancelled out here, guys. C and C gets cancelled out. I get finally 20 into T minus 45, T minus 25 plus 60 into T minus 45 is equal to 0. Okay, if you want, I can do this calculation. It will be 20T minus 25 into 2, 500 plus 60T minus 45 into 2 is 90. 90 into 2 is 270. Okay, 2700 is equal to 0. Okay, am I correct? Am I correct? Yes, I am correct. I am correct. Which gives me, guys, 80T minus 3200 is equal to 0, or T is equal to what? T is equal to 3200 divided by 80, which is nothing but 40 degrees Celsius. The final temperature will be 40 degrees Celsius. No, Tamanna, I didn't cut C with 2C. I can just cut C with C. Okay, I can just cut C with C. Okay, I just cut C with C. Okay, didn't cut C with 2C. Alright, guys, so that was today's class, guys. That was today's class. I want to give you one homework question today. That was today's class. I want to give you one homework question today, and it's a very simple homework question, guys. It's a very simple homework question. Okay, and that is this: I am mixing three liquids. Okay, I am mixing three liquids: liquid 1 plus liquid 2, okay, plus liquid 3. I am mixing three liquids: liquid 1 plus liquid 2 plus liquid 3, which gives me the final mixture. Okay, which gives me the final mixture. Okay, now liquid 1 has temperature of T1, liquid 2 has a temperature of T2, and liquid 3 has temperature of T3. Liquid 1 has mass M1, liquid 2 has mass M2, liquid 3 has mass M3. Liquid 1 has specific heat capacity, Okay, liquid 1 has specific heat capacity of C1, liquid 2 has a specific heat capacity C2, this has specific heat capacity C3. I want to know what will be the final temperature of mixture. The final temperature of mixture. Alright guys, alright. Please tell me this, write this answer in the comments. Tomorrow I'll take the name for both the videos. Whoever gave me the correct answer first, I will take the name for both of them. Write down the answer in comments, okay? And I will take your name if you have given, if you, I will take your name in the class if you've given the answer first before anybody else. Now before you go guys, before you go, let's talk about the very important part of this lecture, and that is the Vedantu's platform. Okay guys, remember Vedantu's platform is there for you if you are a class 11th or 12th JEE or NEET aspirant. Okay, if you take the pro subscription of Vedantu, if you take the pro subscription of Vedantu, then guys you get full access to all live lectures. You get full access to all live lectures from all the faculty members. You get to choose your faculty member. Okay, you get to learn in whatever language you are comfortable, English or Hindi. You get to have your doubts solved instantly in class when I'm teaching, and if you ask me doubt, I have to look at the chat and solve here on YouTube, but not on the Vedantu platform guys. There are class teachers who are there just to solve your doubts, dedicated in class doubt solving. Okay, you can, teacher will keep teaching, the entire class will not get disturbed, and you can ask as many doubts as you want. Just keep asking doubts sorted, doubts, कोई नहीं रोकेगा तुमको, ठीक है? And we have the best faculties in India guys. All our faculty members have 5+ years of experience. They know how to teach. They have taught before for 5 years. Okay, that's a lot of experience guys. They know how to teach. Okay, also you can learn safely from home on any device. You want to learn on your phone, you can. You want to learn on your laptop, you can. Okay, any device you want. You want to learn on your TV, well, Vedantu is coming up for something for that as well. Okay, stay tuned. Anyways, next is, if you want to get the pro subscription, what you do guys, you go to vdnt.in/ytpro. Go to vdnt.in/ytpro and use my coupon code guys. Use my coupon code AAPPRO. If you use this coupon code, what will you get? Extra 15% discount. You get extra 15% discount. Okay, so please go to that guys, please go to that. Also, if you haven't joined our Telegram group guys, please join our Telegram group. It's called the link is t.me/momentum with Vedantu. It's also available in the description. Join our Vedantu group. I will be sharing notes here. Okay, we will share interesting, we are starting new things on the Telegram group guys. We are going to share interesting physics facts on there. Okay, and we will also have physics brain teasers on it. Okay, we are starting a lot of activity on that, so please join our Telegram group. You get the notes, you get the facts, you get the brain teasers, you get to learn physics and also have fun. All right guys, if you haven't joined, if you haven't liked, shared or subscribed to our video, just subscribe to our channel, please do that. Share this video with your friends, show them if they have, especially if they have problem in calorimetry, which many of you will face. Okay guys, in the second lecture of calorimetry tomorrow, we will do the mixing problems and we will talk about latent heat. All right guys, okay, so I'll end this class here today. See you guys tomorrow. Have a nice day. Bye.